Hey all, welcome to your one and only lesson for this short MEA week. We're going to just have a lesson today. You're going to have a short quiz tomorrow, and then you'll still have a work day on Wednesday. So if you have questions about this short week, please refer to the calendar that's posted in Google Classroom, or feel free to leave me anything in the comments, email, or set up a Zoom meeting. So let's get started. Get yourself ready for notes, and we're going to talk about indefinite integrals. So we're going to have homework here from 5.4. So indefinite integrals, if you remember, the idea is to find out the antiderivative. So you're always asking yourself, what function has this as its derivative? So we're going to end up with a couple of the rules just to review. We've got that the integral of any power is equal to 1 over n plus 1 x to the n plus 1. And now we have indefinite integrals, so we're going to add the familiar plus c, since there could be a constant term in there. We also have, if we have a constant, that would equal to kx, now plus c. One other thing that's really helpful to remember is that if we have something like number 1 where we have a sum or difference, is that if you have f of x minus or plus g of x dx, the integral there is the same as the integral of f of x plus the integral of g of x. So you can just take them separately, which is what we're going to do with number 1. We're going to say, all right, well, what's the integral of x squared plus the integral of 1 plus the integral of 1 over x squared plus 1. And these should all have their own dx's, but I'm just being a little bit lazy. So we can go through them one at a time. Here we would have 1/3 x to the third following our first rule, plus x, 1x following our second. And this one is just an integral that I recommend that you memorize, right? This is not going to look super familiar, except for you maybe remember, oh, this is the derivative of tan inverse of x. There's not really a better way to solve it. You just have to remember, oh, that's our old friend here. And then again, as always, plus c. So take each term separately and honestly memorize your inverse trig. They show up a lot because they know, the AP knows that students don't necessarily have them memorized. Now, another place that's going to be super helpful in terms of formulae is that you're going to end up with something like we see in number 2, which is where we have a quotient, which is very challenging to integrate and differentiate, if you think about the quotient rule, but we'll have some of our trig functions that are helpful. So there's 4 trig functions that I just, again, recommend that you memorize. And the first 2 are what we call the double angle formula, which is sine of 2 theta and cosine of 2 theta. And then the other one is sine squared theta plus cosine squared theta equals 1, which can also be written if we divide everything by cosine squared. Tangent squared theta plus 1 is equal to secant squared theta. The double angle formulas are 2 sine theta cosine theta and cosine squared theta minus sine squared theta. These 4 are just super, super helpful, and they will come up on the AP test all the time. So again, just like your inverse trig derivatives, it's just easier to memorize these. So in the case of number 2, we can use that first formula to say, well, that's 2 sine theta cosine theta over sine theta d theta. And the nice thing with that expansion is now we don't have a quotient anymore, because this is now the integral of 2 cosine of theta d theta. One thing that you'll see people do that's absolutely fine is we will factor out the constants, since constants will just be multiplied over just like they would for a derivative. So this is 2 times the integral of cosine of theta d theta. And if you remember correctly, the function whose derivative is cosine is sine. So the integral of cosine is sine theta, and then of course plus c. We're going to finish up with just a couple of theoretical questions about movement. So for number 3, it says a particle moves along a line so that its velocity at time t is the velocity of t is t squared minus t minus 6, where v is measured in meters per second. What do the following represent? So if you remember here, the integral of the velocity curve will give us the displacement, and this is different than distance traveled. This is displacement from, and then we look at the bounds, t equals 0 to t equals 4. And again, remember, displacement is distance from its start, not total distance traveled. For total distance traveled, you would do the integral of the absolute value of velocity, dt. And remember that this is the absolute value of velocity is also known as its speed. And if you want to find absolute value on your calculator, for most of you, you're going to go to math, and then you're going to pick the number category at the top, and then it's A, B, S, and you can type it in like that. So if you want to type in absolute value into your calculator, you can do integrals, definite integrals on your calculator with absolute value in there. It's just fine. Now, when it asks us for the integral of velocity, this will give us another function. This will give us the position function and plus c, and that plus c in this case is its initial position or its starting point. Hopefully this answers some good questions. If you have other questions, please set up a Zoom meeting or leave them in the comments or shoot me an email, and I'll talk to y'all later.